All right. The next small thing that I'd like to mention is the following, is the M&A stamp of an op-amp. Did we discuss this before? Not in the context of M&A, right? So let's say you have an op-amp, and we know that it is in negative feedback. All right. If the op-amp is in negative feedback, so op-amp is ideal and DC negative feedback is present. Under these circumstances, what comment can we make about the properties of the op-amp? There is an op-amp embedded inside a network. We know that the op-amp is ideal in the sense that the GM is infinite or the voltage gain is infinite. And we know that there is DC negative feedback around the op-amp. So what does it mean as far as the network equations are concerned? V1, the virtual short, so V1 equal to V2. And what about is that all? And I1 is 0 and I1 is 0. And likewise, I2 is 0. All right. And what about I3? It can be anything, and that's dictated by the rest of the network. Correct? So therefore, what will be the M&A stamp of an ideal op-amp? I mean, how many unknowns do we need to have an extra unknown? Well, remember that the current flowing through the output of an op-amp is an unknown. So we will need an extra unknown. Okay. And now can you tell me what the structure of the M&A stamp of the op-amp, ideal op-amp should be? Yeah, what do we have in the last row? 1 and minus 1 in which columns? Yeah, so let me, okay, 1 and 2, and you basically have 1 and minus 1. Okay. All right. What else? In the row corresponding to node 3, in the last column, plus 1 or minus 1? It's going outside, so it must be? Yes, Harshit? Plus 1. Very good. All right. Okay, now we come to something interesting. So let's say we had a circuit with 2 op-amps in it, right? So we had a network with 2 op-amps. So let me call this 1, 2, 3, let me call that 4, 5, 6. And again, I'm going to assume that these are ideal op-amps and that there is negative feedback around, DC negative feedback around all the op-amps, right? So to make things clearer, I'm going to basically call this, I'm going to make this op-amp in magenta. All right. Now, how will the M&A matrix be for when we have both these op-amps in? We'll have one more row let's call that I6. This is another unknown. So, we need another row, and so what do we do with that row? Sorry, 4 and 5, right? Four and 5, what do we do? 1, and I'm going to put that in magenta again. It's 1 and minus 1, all right? And then what else? The 6th row plus 1. All right. Now I'm going to do I'm going to draw your attention to something interesting, right? If I showed you this matrix, okay, I didn't show you the picture of the op amps. Of course, you already know what the M&A stamp of the op amp is, right? Now, if I say draw the circuit, what would you do? Do you understand the question? So far, what we have done is gone from the circuit to the M&A matrix, right? Now, I am asking you, here is the M&A matrix, what is the circuit? If the magenta nodes were not there, 4 and 5 are, if the black entries were not there, I am sorry, what would you say? 4, 5 are the inputs, 6 is the output. Okay. Now, when both are there, exactly. So, basically, when you have both present, right, one obvious solution is, I mean, because we came up with it, one obvious solution is to say, oh, well, that's the network, right? But it is entirely legitimate to say well, what do I do? Well, it is perfectly okay to say this is 3 and this is 6. Okay. Both these circuits have the same M&A matrix. Okay. So, what is the moral of the story? Yeah, if both have the same M&A matrix, what comment can we make about the outputs at node 6 and node 3? Do you understand the question? Right? So, these are two, I mean, these are parts of a circuit. In one of them, the op amp, the ideal op amp is connected between 4, 5 and 6, right? And the other one is between 1, 2 and 3. In the other circuit, all I have done is cut off the output from 6 for the op amp in magenta and connected it to 3 and vice versa. Okay? Both networks evidently have the same M&A matrix. So, therefore, as far as the voltages at node 3 and node 6 are concerned, they will remain the same because the M&A matrices are the same. Correct? So, therefore, when you have, so what is the design implication of this? If you have a network with multiple ideal op amps, right, you can actually cut off their outputs and switch them any which way you want, and nothing will change. Do you understand this? Do you understand the the implication, right? let me prove that to you with an example.